Hello, welcome to lesson 4 on the topic time and work. So far, in the first 3 lessons, we have looked at the basic concept of the topic, the importance of using the LCM method, and some problems where we looked at the concept being applied. In this lesson, we are going to discuss some typical questions that are asked in time and work. So the first example, this is example 1. Alright, what is the question? Please listen carefully. A and B can do a task in 90 days. B and C can do it in 120 days. And A and C can do it in 180 days. So what is the change? What makes this question typical? For the first time, all the efficiencies have been given in combined form. In fact, in this example, we are not given the individual efficiency of any of them. Alright? Now, what is the question asked? The question can be, you can frame any question. The first question could be, in how many days will all 3 of them together complete the task? The second question could be, in how many days can B do it alone? And you can frame other questions also. I hope you are understanding. How will we approach a question like this? The first thing that we will do is we will take this as 360 units. So if the total task is 360 units, that means A plus B is 4 units, B plus C is 3 units, and A plus C is 2 units. Alright? So A plus B is 4 units, B plus C is 3 units, and A plus C is 2 units. Now what we will do? We'll add the values on the left hand side. When we add the values on the left hand side, we are going to get 2A plus 2B plus 2C. And when I add the values on the right hand side, I am going to get 4 units plus 3 units plus 2 units. Therefore, from here I can say that twice of A plus B plus C is 9 units. And therefore, A plus B plus C is 4.5 units. The moment I get this value, in fact from here, you are in a position to be able to answer all the questions that can be framed, that can be asked. Let's get back to this example. So what is the efficiency of A plus B plus C? It is 4.5 units per day. What is the first question? The first question is, in how many days will all 3 of them be able to finish the work? The required answer is 360 divided by 4.5. You need to be a little smart. Can I write 4.5 as 9 by 2 and so make it a little easier for me? So this is 40 and therefore the answer to the first question will be 80 days. Alright. What is the second question? The second question is, in how many days can B do it alone? Now, as I said earlier, the minute I get the combined efficiency of all 3 of them, from here you will be able to answer any question that you want. Alright. So we know that A plus B plus C is 4.5 units. A plus B plus C is 4.5 units. But what is A plus C? A plus C is 2 units. But what is the efficiency of A plus B plus C? It is 4.5 units. So if A plus B plus C is 4.5 units and A plus C is 2 units, combining both we can say that B is 2.5 units per day. And therefore, to answer the second question, in how much time can we do it alone? If you allow me to use this space, so this is 360 divided by 2.5, so 360 I can write it as 5 by 2. This is 72 and therefore this answer will be 144 days. The first typical question, the first typical example that I wanted to share with all of you. Okay? Please remember this. Let us move on and look at the second typical example. Alright? So what is the learning from the first typical example? If I am given efficiencies only in the combined form, then how do I attempt a question like this? Alright? Now let me take you to example 2. Let me take you to example 2. Now this is a beautiful question and we all need to learn how to handle a question like this. Please listen carefully. A and B can do a task in 12 days and B and C can do it in 16 days. Alright? A and B can do a task in 12 days and B and C in 16 days. Now, in completing a task, A has contributed for 5 days, B has contributed for 7 days, and C has contributed for 13 days. Alright? So while they worked in completing a task, A contributed for 5 days, B contributed for 7 days, and C contributed for 13 days. What is the question? You can have various questions. Let me take the first one. In how much time can C do it alone? Let me take another one. In how many days can B and C do it together? Let me take a third one. In how much time will all three of them will be able to complete it? Okay. So before we start this discussion, I want all of you to appreciate the difference between example 1 and example 2. In example 1, we had 3 variables and we had 3 equations. The challenge is, in example 2, I still have to deal with 3 variables, but there are only 2 relations. And therefore, there is a definite way of understanding and approaching a question like this. Let us see. What we will do, we will take the total work as 48 units. So A plus B will be 4 units and B plus C will be 3 units. Alright. Now let us see the question very carefully. A has contributed for 5 days. But do you have the efficiency of A? No. You have the efficiency of A combined with B. So therefore, to begin this question, the first thing that we will have to do is A plus B worked or contributed for 5 days. I hope you are understanding. A plus B contributed for 5 days. So in doing so, I have taken the 5 days that A contributed and I have taken the 5 days that B contributed. So how many days still left as far as B's contribution is concerned? 2 days left. But do I have B's efficiency now? Yes, I do have, but it is now combined with C. So therefore, what I'll have to now do, I'll have to now say that B plus C worked for 2 days. Why 2 days? Because we have only 2 days remaining for B. And in doing so, we have taken C's contribution for 2 days. How many days did C contribute? 13 days. We have already taken 2 days. So how many days remaining? Remaining is 11 days for C. And everything put together, so this plus this plus this should be equal to 48. Alright? Can we actually put the values now? So what is A plus B? 4 into 5 plus. What is B plus C? 3 into 2 plus 11 into C is 48. So this is 20, this is 26. If I take it to the other side, I will have 11 into C is 22 units, and therefore C is 2 units per day. The minute I am able to get this, from here I'll be able to answer all the questions that can be possibly asked. So what is the first question? The first question is, in how much time can C do it alone? It is 48 divided by 2, so that is 24 days. The first question. Alright. What is the second question? In how many days can B and C do it? B and C do it. So what is the efficiency of B plus C? Do I have the efficiency of B plus C? Okay, I know that B plus C is 3 units. So B plus C is 3 units. Therefore, 48 divided by 3, this is 16 days. So this was anyway direct question. We need not have even solved this for that matter. Alright. Okay. What is the third question? In how much time can all three of them do it? So I need to find out the efficiency of A. Now this is interesting. From where will I get the efficiency of A? A plus B is 4 units. Alright. So if you allow me to take this, rub this particular part so that we can do this easily. Alright. So I know that A plus B is 4 units. But if I have to calculate for A, then I automatically need to know the efficiency of B. So what we'll do, we'll start from here. How? B plus C is 3 units. What is C? C is 2 units. From where am I getting this? I have already solved this. So C is 2 units. So therefore B will be 1 unit. Now what we will do? We'll take it and plug it here. So what is A plus B? A plus B is 4 units. And what is B? B is 1 unit. So what is A? A is 3 units. So C is 2 units, B is 1 unit, A is 3 units. So what is A plus B plus C? 3 plus 1 plus 2. This is 6 units. And therefore, what is the question? In how much time will all three of them complete the work? If they work together, it is 8 days. So students, in this lesson, we have looked at 2 typical and yet beautiful examples of the application of